Hi, everybody. My name is Kai Fox. I'm an instructor at the Sustainable Agriculture Program in Winter Community College. Appreciate the opportunity to talk. I think, again, a lot of the stuff that I'm going to go over, both Lynn and Louisa have covered fairly well, but it's always good to hear things over. So I'll just start with that. Oh, yeah, so I'm going to be going over potential food quality process concerns and potential food safety hazards. Kind of a big title, but basically just kind of trying to identify places where these concerns might occur in your system, in your farm. So first, I just wanted to kind of summarize the industry as it stands now. It's aquaponics is obviously a very old technology, but modern aquaponics using modern materials, metals, plastics, electricity, that kind of thing is relatively new. And in the past couple decades or so, it's really picked up steam and is now really on the cusp of becoming widely accepted as a commercial operation. And there's a lot of different approaches to it. And I think there's two major ones that are sort of coming to the front now. And one is the one that is very common in our state, which is linked to a recirculating aquaculture system, which we call coupled. It's a fully recirculating system where the fish water is shared with the plants and filtered and sort of recirculated. But there are also other kinds of systems that are separated. You have the separated fish and plant components where the water is essentially reused once, but it's unidirectional, and that's a decoupled system. So I just wanted to kind of make that distinction. In both systems, it's become clear that commercial fish feed is lacking in some micronutrients specifically. And so oftentimes in commercial operations and backyard operations, there are supplements like additions for micronutrients that are applied, usually just for the plants. So in both coupled and decoupled systems. And recently there was a review article came out this year, and I'll provide the references, very good article by Paul and colleagues, published by the European Union Aquaponics Hub. They're really trying to get a handle on the nomenclature, because aquaponics means a lot of things to a lot of different people, but this is becoming sort of the accepted definition of what aquaponics is, and I'll go through it. I just think it's important just to point it out to begin with. So aquaponics is a production system of aquatic organisms and plants where the majority, that's greater than 50% of the nutrients sustaining the plants, derives from waste originating from feeding the aquatic organism. That's a mouthful, but essentially it means that more than 50% of the nutrients supplying the plants has to come either from nutrients dissolved in the water from the fish, or nutrients that when you process the fish waste, it's dried and it can be applied to the field. So it's just trying to get the concepts out there. So I wanted to start with food safety and sort of some control points that are looked at by these third-party auditors. Excuse me. And again, these are issues that we've already heard about. So worker issues. These are things to always be concerned about. Sanitations, in terms of washing hands and washing produce. I mean, a lot of these food safety issues happen because of human pathogens transferred from human to produce to human. Also, management issues, trainings for the workers, policies that you've implemented on farm, and of course, your third-party audits. And generally, there's three kinds of food safety, food quality issues, and chemical is like pesticide, herbicide, that kind of stuff. Physical can be metals and plastics and stuff that get caught up in the produce and that get processed and packaged for the consumer by mistake. And then microbiological, and that's the one that I'm going to kind of focus a little more on for this talk. So aquaponics in our state, we have a tropical climate, a year-round growing season. So we have a lot of pests year-round. So we do have to deal with that. This picture is not photoshopped, and it's funny that both Lynn and Louisa were talking about this, but this was a research, this is the grow bit of a research system at a CTAHR facility. Actually, a chicken got really comfortable and laid some eggs in it, so it does happen. So we have outdoor pests like slugs and in our state. Rat lungworm infection is becoming a big concern. Mammals and of course birds. And again, aquaponic systems, the design of aquaponic systems vary quite a bit. And so that's something to take into consideration. Okay, so real basic system design. In general, aquaponic systems have 3 components: fish tank, biofilter, and grow bed. And you know, Lynn went over this a little bit. This is a sort of a cartoon of a typical recirculating system. So the water is recirculating back and forth through the fish tank, biofilter, and grow bed. But these are the basic components I wanted to focus on. So the potential for food safety hazards. The first potential when you're talking about inputs to the system is the fish. And where did the fish come from? Did you catch it from a stream? Did you get it from a commercial grower? And Ruth Ellen is going to talk in more detail about this, so I'll just leave that for now. But these are just some of the issues. Fish food quality is a kind of a big deal as well. How do you treat your food once you receive it from your supplier? Is it properly stored in a cool, dry place? Essentially, you should think of your fish food as almost raw meat. It is processed fish meal, but it's added fat and other volatile components that are excellent food sources for microbes as well. So this is a place where food safety can come into play. Mortalities on your farm, fish, how quickly you get them out of your system. If you do find mortalities, you know, decaying fish bodies are a potential safety hazard. Pathogens that can be transmitted from fish to humans, or zoonotic pathogens, and I think again Rutella is going to talk about that. But that's a concern. And then generally in the fish tank, your water flow. You want to make sure everything is moving. There's no dead zones, no anaerobic zones, that kind of thing. The next component is the biofilter. And in general, this is where the bacteria live. This is where your fish waste is processed from ammonia to other nitrogenous products that the plants take up. And biofilters can be complicated or very simple. Oftentimes, like Lynn said, there's a solid separation component where the solids are filtered out. This zone is usually anaerobic, without oxygen, and so you can have different kinds of potential safety hazards with anaerobic zones. And then there's also aerobic zone where the nitrification happens. There can be, if it's a solid media system, like I showed with the chicken eggs, there can be, you know, animal contamination in there. They make nice homes for feral animals. The media itself is a potential food safety hazard if depending on where you got it from, how you treat it, if you clean it. Composting worms and their castings. Typically, I mean, these are just, again, just identifying possible safety hazards. Not saying they are hazards, but you know, you don't want to be digging up your own composting worms from a piggery and dumping it in your aquaponic system, for example. The plumbing, the siphons, the drains, that kind of stuff, depending on your flow rates and how often you clean them, you can have organic buildup. These can all be, you know, sites where food safety hazards should be identified. And again, invertebrate contamination, slugs, that kind of stuff in our state. The grow bed is also this final component here. Same issues with the grow bed and the biofilter, depending how it's constructed. Animals, media, plumbing, water flow, and again, like Lynn pointed out, you know, splashing, identifying areas where you want to keep. If it's a raw edible product, you don't want to have the aquaponic water touching the raw edible portion, and that has to do with harvesting as well. So I'm just gonna the last part of this talk. I'm just gonna go over a study we did with Louisa, and that's Dr. Clyde Tamaru when we were in the Cooperative Extension Service. And this is a fairly old study. It's, I think, from 2011-ish, around there. But we did this study sort of in response to third-party auditors being hesitant to conduct audits with aquaponic farmers. So we wanted to actually do what we've all just been discussing. Identify areas where there may be contamination or hazards, and try to get some scientific data to just get scientific data, because it didn't really exist at that point. So this first graph looks a little crazy, but essentially this is the water. This is aquaponic water. What we did was went to 3 different islands. We tested, I think, about 11 different farms and got a geometric mean. This is a standard practice for estimating bacterial content in irrigation water. This is one of the aspects of the third-party audit that was of greatest concern in the beginning. And we basically found that every farm we tested was well within the limits that were acceptable for a third-party audit based on national standards, with the exception of one farm. And one farm actually was using surface water as a input to their system. All the other farms were using municipal water. So I think that was one clear finding we found, that you should always use municipal water and not surface water. As far as inputs, I was talking about additions. Fish food obviously is one of them. For organic aquaponic growers, sometimes bone meal, kelp meal, products like Sustain are used to supplement micronutrients. We did a variety of testing on several of these products. We looked for pathogenic E. coli, salmonella, and we were never able to detect any kind of contamination. We also looked at the fillets of fish living in green water aquaculture systems, as well as recirculating aquaponic systems. We looked at the water that the animals were living in, and they had low levels of the generic E. coli. Like I showed in the first slide, the waters had detectable levels of E. coli, but they were well within acceptable standards. But we never detected any kind of pathogenic bacteria in the mussel itself, the harvestable portion of the fish. We also tested a wide variety of fruits and vegetables that were grown aquaponically from a variety of different farms. Same thing, E. coli, salmonella, didn't find anything. So I guess in general, this, as a summary, aquaponics, it provides a very clear, nice model for inputs and outputs. It's different from a lot of other traditional farms in that sense. So it is possible to develop a HACCP, the Hazard Analysis and Critical Control Point plan, and I think that's ideal for an aquaponic farm. If you can do this, this is probably a good idea. It's also a good idea to limit pesticide use in your aquaponic system. Obviously, a lot of farmers do that already because it affects all the different aspects of the aquaponic system. But this is a sort of a food quality, food safety issue. You want to use food safe material for construction for sure. To get organic certification, you already have to do this, but I think most farmers are responsible and they do this anyway. But just to reiterate that, it's a good idea to build systems that can be easily taken apart for maintenance and cleaning. That if you Schedule 40 PVC that has true union fittings as frequently as possible, they're expensive, but just the ability to, or male adapters where you can unscrew pipes and clean them, trying to design the system so that it can be easily cleaned and maintained. And of course, to use only potable municipal water for startup and refill of your aquaponic system. And with that, I have the references of the talk.